Hi, I am Zheng Yuxie from Shenyang University. Today, I would like to introduce our new work on Cvpr 2023 for image-based virtual try-on. To begin, I will provide a brief overview of our contributions in this work. Firstly, we propose a unified try-on framework named Gp-Vton that generates photorealistic results for diverse scenarios. Secondly, we propose a novel LFGP warping module that produces semantic correct deformed garments, even with challenging inputs. Thirdly, we introduce a simple yet effective DGT training strategy for the warping network that ensures distortion-free deformed garments. Finally, extensive experiment onto challenging high-resolution benchmarks demonstrates Gp-Vton's superiority over existing state-of-the-art methods. Given a source person and a target garment, image-based virtual try-on aims to transfer the garment onto the specific person while preserving the source person's identity and the target garment's characteristics. However, existing methods typically fail to handle challenging inputs. When provided a source person with intricate pose or a target garment with long sleeve, existing methods fail to preserve the semantic information of different garment parts. Besides, existing methods are prone to generate distorted texture around the boundary of the upper and lower garment. To address these problems, we exploit the local warping flow for semantic correct garment deformation, which conducts local warping for different garment parts. We also employ the Global-Parsing to combine different local warp results. Furthermore, we introduced a novel training strategy for distortion-free deformation. Our method consists of a garment warping module and a try-on generator, in which our local flow Global-Parsing warping module and dynamic gradient truncation training strategies are designed for the garment warping module. Specifically, the LFGP warping module tests as inputs the garment-related inputs and the person-related inputs, and then estimate several local warping flow maps and a global parsing map, in which the local flow maps are used to deform different garment paths, and the global parsing is used to integrate different warp paths into an intact warp garment. Finally, the try-on generator tests the warp garments and the other conditions as inputs, then generate the try-on results. For LFGP warping module, it consists of a person encoder, garment encoder, and cascade local flow global parsing estimation blocks. Each LFGP estimation block consists of 2 flow estimation blocks and 1 parsing estimation block. The flow estimation block takes as inputs the person feature, garment feature, and the previous estimated flow, then output the current estimated flow. The parsing estimation block takes as input the person feature, garment feature, and the previous estimated flow, and then output the estimated parsing. Existing methods neglect the wearing style of the target person and directly penalize the overlapping region in the warp garment. In contrast, our DGT training strategy dynamically penalizes the overlapping region according to the wearing style of the target person, in which the wearing style can be defined by the difference between the height-width ratio of the GT warp garment and that of the flag garment, and the height-width ratio of the garment can be calculated according to the torso region in the garment parsing. We conduct extensive experiments onto widely used try-on benchmarks, namely Vton HD dataset and JSCode dataset. The qualitative comparison on Vton HD datasets shows that our Gp-Vton is more robust to intricate pose or complex garment input and can avoid texture distortion, both of which leads to more photorealistic trial results. The qualitative comparisons on just code dataset further shows that our Gp-Vton can outperform existing methods in different category trial scenarios. Furthermore, the quantitative comparisons shows that our Gp-Vton can surpass the baselines on all matches for Vton HD dataset and obtain finest scores on most matches for just code dataset, which illustrates that our Gp-Vton can generate trial results with better visual quality. The consistent improvement on MIOU matches for both datasets further demonstrates that our Gp-Vton can obtain more semantically correct warp gammons. We also conduct aberration studies to validate the effectiveness of the LFGP warping module and the DGT training strategy. As shown in Fig A, by using the Global-Parsing for warp path combination, the overlapping artifacts between different warp paths can be eliminated. As shown in Fig B, by using DGT training strategy, the warp results can avoid texture squeezing or stretching, therefore leading to distortion-free warp results. As shown in the quantitative results, using local flow warping can result in higher NIOU scores, illustrating better semantically correct warp results. On the other hand, using DGT training strategy results in lower height-wise difference scores, illustrating better preservation of the garment shape. This is all my presentation. Thanks for your listening.